Hello all, I welcome you all to this session on C++ programming. So in this lecture, what we'll do, as we have learned about the structures in the previous lecture, so we will continue it. But this time, we are taking one problem of a two-dimensional array. So now, this problem is saying that we have to write a code for matrix such that we can declare it, we can add another matrix to it, we can display the matrix, and then we have to convert that into a structure so that it becomes a standalone matrix. Okay, so let us start with the program. So where is it now? It says that I should have one array having dimensions m rows and n columns. I should have B with m rows and n columns, and I should add them in this particular matrix with now let's change the name to, let's say, C. M rows and n columns, if you add m cross n to m cross n, the result will be m cross n only, and D will be storing the difference, so it is m and n. Now, am I permitted to do this? No, because before you declare it, you should have the number of rows and columns. So let us do what? Let us declare it here. Const int m is 3, and similarly const int n, and it is also 3, let's say. Now it is valid because during compile time these m and n will be created first, and then it will read this particular statement. Now what I have to do, I have to write a function such, let's say, add, which should be capable of accepting a and b and returning the result in C. Okay, got the point or not? As well as I have to write a function, let's say, subtract, which should be capable of taking a and b matrices and return the result in D. Now, I should also have one function. If you look the problem, it says get matrix. So I should have this get matrix function, and it should be doing what? It should be taking one matrix with it and filling the data into it and then coming back to the main. So I should have these. Apart from this, I should also have this functionality, that is the matrix display. So the name of it is display matrix. So inside the program, I should also have this display matrix, and let's say it is displaying the sum, that is C, and the difference, that is D. Okay, so this all I have to do. What I have to do? I have to write these functions. So how to write them? The first thing is, let us write the function for taking the data or transferring the data into the matrix. So void get matrix. Okay, now it is accepting what? It is accepting one integer two-dimensional array A, m and n. Always remember, while transferring a two-dimensional array, this is optional, but this you have to provide, because what in real time happens inside the memory, the array is not saved as rows and columns. It is a contiguous memory allocation saving there. So the compiler will break at the point where n is. So you should always remember this. Now another array, it will take, what is this? Let's say it is B. These are just the dummies. Okay, and then int C m and n. That's it. So here inside this, what will happen? Okay, as this is a get matrix, so I cannot write like this. Only one matrix it will be taking. I was just thinking in different way. I was trying to make this add. Okay, now what I have to do, I have to run a loop for int I0, I less than m, because m rows are there, and I plus plus. Then for int j is 0, j less than n, j plus plus. Then what I have to do, I have to transfer the values. So cn a I j, I and j. That's it. So simple. And if you want this program to look more elegant, what you can do is simply say cout, enter, then space, and then what, I plus 1, then row, and enter. So this will do what? It will say enter first row, enter second row, enter third row, and so on. Now once this is done, then you can also create this matrix, display matrix right now. How? Let us see. So again, that will be void. Now you know why we are taking it as void, because this is basically doing what? We are transferring the matrix itself, and this is taking the address of it. Okay, so there the name of the matrix itself, the address. So it is working on that. It is just transferring the data there itself. So that is why we are just returning void, nothing, because it is working there in the calling matrix itself. Okay, now get matrix is over. Now we'll come to display matrix. So this is the display matrix. Okay, what it has to do, this is no need. Now it will simply say cout and then aij, and then let us give some space so that it look better. Once one particular row finishes, then come to the next line. Done. It is also done. Now comes the addition part. Now we have to write a function for addition. So what we'll do, we'll paste the same code. Oh, where's the code? This is the one. We will paste this particular code here and just change the name to add. So I'll say add. Now it will be taking 3 arguments. So this is matrix B, and this is taking another matrix where it will be storing the data. Let's say it is C. So here inside we have to slightly change that Cij I j will be what? It is nothing but Aij plus Bij. So it is I, this is j, this is I, this is j, and that's it. It is done. Now you have all the functions ready with you. So what this add will do, it will take A, B, and it will transfer the data to C. That's it. You can also make one for subtraction. So let's say it is again C, doesn't matter. So it is subtraction. That's it. So now you have all the functions ready with you. And what I'll do is I'll make it 2 because I don't want to type more number of terms. Okay. Here, to make it better, you can say simply cout, enter first matrix, and once this is done, then you can do what? Enter second matrix, and here I'll pass B. Once these are entered, then addition and subtraction will be done. Then you can also say cout the result of addition is L, and here you can say the result of subtraction and this is the one we are subtracting because we are using this particular function. Then friends, it is so simple. So if you run it now, oh, it is having some problem. Yes, it should be subtract. The name should be subtract. Look, this is sub. Okay, now if you run it, it will be asking for the first matrix. So let's say it is 1, okay, 1, 2. First row, the second row is let's say 2 and 3. Then the for the second matrix, the first row again let's say it is 1 and 2, and the second row again let's say it is 2 and 3. So the answer will be 2, 1 plus 1 will be 2, then this one becomes 2, and 2 plus 2 will be 4, then this is 2 plus 2 will be 4, and 3 plus 3 will be 6. So we are not getting any spaces. Why? We are not getting any spaces. We have asked it to. Okay, this is the problem. So again, if you do it, 1, 2, 3, 4, let's say 2, 3, 4 and 5. So if you add 1 and 2, the result will be 3, then 2 and 3, result will be 5, then second row 3 and 4. 3 plus 4 7, and then 4 plus 5 is 9. And if you subtract 1 minus 2, it was minus 1 and so on. So this is how you can write your functions which can accept matrices and work on the address of those matrices and give you the result. Okay, now that's all. Now if I have to convert this into structure, so how can we do it? As majority of the work you have already done, so now it is only a very simple task. So let us convert this function into structure. So let us make a structure known as matrix. Okay, now inside this structure we will be declaring this. Okay, we have declared them. Oh, sorry. Okay, now inside the matrix itself we should have one function, get data or get matrix. So what we'll do, control X, this. Now have you noticed anything? You should notice, and the thing is we have not declared any variable inside in terms of matrix form. It should have. So int a, and now it is mn. This you should never ever forget, because the identity of matrix is this. First the mn, okay, and then the matrix itself, that is the array. Now get data of what? A. So you needn't have to pass anything now, because that is in the matrix itself. Okay, so this, let us bring it right. Okay, now so get matrix is done. Then display matrix, again we will bring it there inside the structure. So let us also bring it slightly towards right. Okay, done. Again, as this is function of the matrix itself, so what it will accept? Nothing. It will simply display that particular thing. Okay, now the addition, let us make the functionality also. So here you bring inside, you keep everything aside. Now this will be, now this is something which you should understand. Adding a matrix, what? Adding a matrix means you are adding something to something. And here we will be following the same policy which we have followed in the last lecture. So here what we will do is, we will add aij of this particular structure to the aij of another matrix. So let's say that another matrix is, let's say, x. Okay, and to this aij we are adding the x dot aij of x. Remember, that is what we have done in the complex number, similar thing. Okay, and let us say that it is returning what? A matrix. So that what can we do? We can do what? We can also say matrix, and let's say c m comma n is the c m comma n is this particular matrix. So do we have to define it like this? No, not at all required. So this matrix C is the one where the data is being transferred every time. Okay, and what is that? That is basically this C dot aij. So aijth location the data will be transferred. So in this way you can make your program of structures for matrix to take another matrix, add to the data of that particular structure itself, and then transfer it to some local variable, let's say C here, okay, and to the aijth location, and then return what? Return C. That's it. The same thing you could have done for difference also. So instead of add, I can write subtract, and here it will be only minus. Simple. Now you have your subtraction, you have your addition, you have your display, okay, and you have your get data, everything you are having. Now inside the main, what you have to do now, what is this? This is not required anymore. Okay, now inside the main program you should have what? You should have a, and now we will be declaring it as matrix. So this is A, this is B, this is again C, and this is D. Now you know why we are not writing like this, because the matrix is no more, matrix is full-fledged matrix for us. It is like having m with it, it is having n with it, and it is also having one am comma n with it. Now this is basically that particular array. Okay, so the data elements for this particular structure is m, n, and am comma n. So you should understand this. So if you want to transfer data to this particular matrix, so what you will say? You will simply say a dot get. Now you can see that this is having get matrix with it. Okay, done. So simple. Now the same thing we can do for B. So what I'll say, B dot get matrix. It is also having it. Very good. Okay, now once these two are done, so what is our next task? What is the next task? The next task is to add two matrices. So the next task is to add two matrix, and the addition should be taken up by some another matrix. That is what this particular addition is saying. Adding to a particular matrix, to a particular structure, another structure, this is nothing but one. There is a mistake again. This should be what? This should be a matrix. Okay. So you should always be cautious while writing these things. And matrix always have m and n. So there is no point of writing this. The same thing you can do here. This is matrix. Okay, now what we'll do is we will add. So add, how we'll add? So we will take this C and we will say a dot add what? B. That's it. Similarly, in D we can say a dot subtract B. That's it. Now we have addition, we have subtraction. Now what we have to do? Display the result. So display the result. Now C is a metric structure, remember. It's not an array anymore. It is a structure now of name matrix. So it is having what? Addition, subtraction, display also it is having. So what we can use? We can use this particular. So if you look, C dot now display matrix, this function I'm using. That's it. Simple. Likewise, here I can say D dot display. That's it. We have done with it. So what we have done is, once more, we have created a structure known as matrix with data members m, n, and this array. Then get data. We are enriching this particular array. Now that means initializing it. Then display. Okay, we are displaying this particular array, means this particular structure matrix itself. Then we have made one function add, which is accepting another matrix x, and it is adding the x aijth element to aijth element of the current matrix. That means current structure C. If the current structure is A, so it is adding A to adding, let's say it is taking B as the argument, so it is adding the B's aij to the current matrix Ath aij. So that is what it is doing, and it is storing it in matrix again. Okay, and that is our result. The same thing we have done for subtraction. So if you run it now, so there is a problem. The problem says int a and then a, m, and n. Okay, so what is the problem? We have to ponder upon this particular thing slightly. So what we have to do is const is okay, but we have to make it static. Okay, now we have to make it static because otherwise it will not work. Now if we make it static, whole thing is so simple. Now we will let us write the first row. It is 1 and 2, second row 2 and 3, let us 4 and 5, and let's say 1 and 2 again. So the result of addition is this, result of subtraction is this. So friends, in this particular lecture, what you have learned is, you have learned a very simple thing, that how to make write a program for matrix addition, subtraction. In future you can also make it for division as well, not only from the point of view of simple functional form, but you have also created one structure for it, and structure is doing everything. So this is the beauty of C++. You can add functionalities to these structures. So in this lecture, till this point only, thank you very much.